I'm going to let that sit up there for a minute or so that you can read the question and brainstorm before I start to solve the problem. Okay, here we go. It can help to draw a picture of the rectangle. Not the best rectangle I've ever drawn, but just give me some artistic license again. But drawing the picture is not very useful if we don't label some things. We have that the width of the rectangle is 12 inches less than twice its length. It's not saying that the width of the rectangle is 12, it's saying that it's 12 inches less than twice its length. So let's say we have the length labeled here, the side opposite would also be labeled with an L, and then the width is 12 inches less than twice its length. Twice its length would be 2L, whereas 12 inches less than that, take away from 2L, that 12, we'd have 2L minus 12. Now you may have seen different problems about rectangles, such as, besides this question being about the area being 100 square inches, yeah, there are other questions that involve perimeter, but you wouldn't have anything in square inches there. And also sometimes we might talk about the diagonal and wind up applying the Pythagorean theorem, but that will be talking again about lengths of things. You know, if you use the Pythagorean theorem, maybe you'd want to talk about the length of the hypotenuse. There wouldn't be any discussion of square inches. So we need to make sure that we're using the correct formula here. Area is length times width. I'm going to fill in that we know the 100 square inches. And for W, we have filled in the 2L minus 12. To recognize this as a quadratic equation, we're going to have to distribute. And to be able to solve this by completing the square, we do have the constant term isolated, the terms with the variable, in this case L, all on one side, but we don't have a 1L squared. So I'm going to divide all terms on both sides by 2. I've also put the constant term on the right hand side instead of what we had here. For our side work, since now we have a 1L squared, in front of L to the first we have -6. -6 divided by 2 is -3, and then we square that. We're going to be adding 9 to both sides. Making the left-hand side a perfect square trinomial, which we can rewrite looking back at the first step of side work, so that we don't have to think too hard about how to factor L squared minus 6L plus 9. Apply the square root property. It's going to cancel on the left. We don't want to forget the plus or minus. And so we get the length is either 3 minus the square root of 59 or 3 plus the square root of 59. But square root of 59 is approximately 7.68. One 4 5 7 4 8. I meant to include this in the directions here. We're going to approximate this to the nearest tenth, but we're going to save that approximation until the very end. Thing is, 59 is not a perfect square, and the only perfect square that goes into it is 1. So, having come up with this approximation, since it's an application problem, they're going to want to know to a certain degree of accuracy. Well, if we subtract 3 minus the 7.68, that's going to give us negative 3.68 1145 748. And since the comparison of the length and the width was in inches and the area is in square inches, this length would be in inches. That doesn't make sense to have a negative. So we reject that. Whereas if we add our approximation of square root of 59 to 3, we're going to get that L is approximately 10.68 1145 748. And as I said, I meant to write this in the directions, but if we're rounding this to the nearest tenth, then L is going to be about 10.7 inches. asking for the dimensions is asking for both the length and the width. Just in case, I'm going to take the more exact version. I'm going to double that and subtract 12 to find the width. So when we take 2 times the 10.68, 1145, 748, and subtract 12 from that, multiply first, then subtract, we get that W is approximately 9.3622, 915. If we round that to the nearest tenth as well, it's going to be about 9.4 inches. And just going to check something here real quick. Okay. Notice how I labeled which one's the length, which one's the width, and I included the unit that we are measuring length and width in, both being in inches.